Hello, my name is Mr. Asprey and this is another MadAsMaths MP2 paper. This is paper B, difficult rating 3.8, which I think is out of 5, not quite sure. But it's a really good paper, give it a go. There's a fantastic trig equation to solve, which is a really good one, good practice there. And there's also a really good implicit differentiation and integration by substitution. It's just a fantastic paper, so give it a go, watch the solutions, and if you do find it useful, please do subscribe to the channel. Please do like it and please do share with anyone else doing A-level maths. Okay, let's get into it. Question 1 is a differentiation by first principles. So we need to know the formula, which is that f dash of x is equal to the limit as h tends to 0 of f of x plus h minus f of x all over h. So as we are differentiating sine, we would write the limit as h tends to 0 of sine of x plus h minus sine of x, again all over h. So this would give us, when I use my compound angle formula, I will get sine x cos h plus cos x sine h minus sine x, and again all over h. And then we can do some factorising. I can take out a sine x of the first and third terms, which will give me cos h minus 1, and here I have plus cos x sine h, and I can write this side over h and this side over h, and we do that because we are given this, and we are given this. So we say as h tends to 0, f dash of x will equal, well, this blue bit here will tend to 0, which means that left fraction there will be completely 0, and this green bit here will tend to 1, so we're just left with cos of x. Question 2, we've got a sequence of numbers defined by this iterative formula. We get told what the first digit is, and we're asked to work out the sum of the first 20. Okay, so we need to find a pattern, so we need to just work out what each term is. So the first term is 2. If I sub 2 into my formula, then I sub 2 into this term here, which is the term before the one we're trying to work out. So u2 is equal to 1 over 1 minus 2, which is equal to minus 1. And then u3 is equal to 1 over 1 minus minus 1, which is equal to a half. And then u4 is equal to 1 over 1 minus 1 half, which is 1 over a half, which is 2. Okay, fantastic. We've got a repeat. So therefore this sequence is periodic order 3. So it takes 1, 2, 3 jumps to get back to the starting point. Okay, if we want to work out the first 20 terms, then we will divide 20 by 3 because that's the order, and we will get 6 2/3. So that means that we can have 6 lots of the of u1 plus u2 plus u3. That will be the first 18 terms, just u1, u2, u3 happening 6 times over. That will give us the first 18 terms. And then we're back to u1, and we'll also need a u2 to get to the 19th and 20th. Okay, so this is 6 times by 2 plus minus 1 plus 1/2 plus 2 and then plus minus 1. Okay, so we can calculate this. That's 1/2 times 6 is 9, and then we've got plus 2 minus 1, so that's a total of 10. Question 3, we've got a set of parametric equations and we're told that the point P lies on the line. Okay, so that means that the x coordinate must satisfy the x equation. So I can write 2 over 5 is equal to 1 over t plus a. I can flip both sides of that to give me 5 over 2 is equal to t plus a. Okay, obviously I can't solve this because I've got two unknowns here, a t and an a. So what I'm going to do is use the second equation, which is y, and the coordinate for y satisfies that. So I get minus 2 over 3 is equal to 1 over t minus a. Flip that one to get minus 3 over 2 is equal to t minus a. Okay, great. So I've got two equations now, both with two unknowns. So we can solve them simultaneously. And what I'll do is I will call this one 1, this one 2, and we'll do 1 plus 2. So 5 over 2 plus minus 3 over 2 is 2 over 2, which is just 1. And t plus t is 2t. And then the a's will cancel out perfectly. Great. So t is equal to 1/2. And then subbing back into equation number 1, this gives me that 5 over 2 is equal to 1 over 2 plus a. So a must equal 2. Okay, we need to differentiate to find the gradient. So what I'm going to do is I'm going to write now x is equal to t plus 2, because a is 2, to the minus 1, just easier to differentiate like this, and y is t minus 2 to the minus 1. Now if I want to find dy by dx, I need to differentiate the y with respect to t, then divide it by differentiating the x with respect to t. Differentiating the y, the minus 1 comes down to the front, bracket stays the same, drop the power down by 1, and times by the derivative of the bracket, which itself is just 1. And let's differentiate the x, the minus 1 comes down to the front, t plus 2, drop the power down, and again the times by the derivative of the bracket, which is 1, so we don't need to do that. Minus 1s will cancel. We've got negative powers here, which means they're reciprocals. So I can get rid of the negative power and send that one up to the top, and get rid of the negative power and send that one down to the bottom. So this will be t plus 2 squared over t minus 2 squared, and I can write this as t plus 2 over t minus 2 all squared. Okay, we need to work out the gradient at the point P, and we've already worked out that at the point P we have a t value of 1/2, so we can use that. So dy by dx at P is equal to 1/2 plus 2 over 1/2 minus 2 all squared. So that's 5 over 2 over minus 3 over 2 all squared. 2's will cancel because we've got 1 on the top, 1 on the bottom. So this is 5 over minus 3 all squared, which is 25 over 9. Lovely. Question 4. It's a bit horrible, loads of parts to it, and it's a bit fiddly. Anyhow, let's do it. Parallelogram ABC. So the first thing I would do is I would just draw a parallelogram like such, and I'd make sure I'd labelled it in the same order that it's written. So A, B, C, D, and then what I'll do is I'll put a fixed origin down the bottom somewhere. Okay, so which are the ones we know? We know A, B and C. So I can go A, B and C. We know those. And D we don't know, and D is what we're trying to find out. Okay, so we really want OD, the position vector of D. So what we can do is we can go to A, because we know OA. And then ideally we want to go across AD, but we don't know AD. What we do know is it's the same as BC, because it's parallel. And it's a parallelogram, so they have the same distance. So I can just add on BC. Okay, now how do we work out BC? Well, BC is OC, whoops, let's put a plus there, is OC minus OB. Okay, great. So we need A, which is 1, 1, 2. Add OC, which is 4, 0, 1. And minus OB, which is 2, 1, 5. Okay, so what's this going to give me? On top we've got 1 plus 4 minus 2, which is 3. We've got 1, 0, minus 1 is 0. And 2, 1, minus 5 is minus 2. Okay, it asks for the coordinates, I believe. Yep, so we can't give it as a position vector, we have to give it as a coordinate. So as a row, like so. Hey, that rhymed. Nice. Okay, next part, that was part A. On to part B. It says that E, B and D are collinear, which means they lie on a straight line. Like so. And it says that B is the midpoint. Okay, so that means that this is the same distance from D to B as it is from B to E. Determine the coordinates of E. Okay, and we know D now. Okay, so from D to B, it's the same movement as from B to E. So how do I go from D to B? Well, let's write them down. We have 3, 0, minus 2. And then we're going to B, which is 2, 1, 5. And if we carry that on, we're going to get to E. So 3 to 2 in the X, so that goes down by 1, so it's going to go down by 1 to get to E. 0 to 1, that goes up by 1, so 1 up by 1 is 2. And minus 2 to 5, it adds 7, so add 7 is 12. And this is our coordinate for E. Okay, it says the point F is such that ABEF is also a parallelogram. Find the coordinates of F. Okay, so once again, I'm going to draw another parallelogram, like so. And I'm going to label it around in the same way. So we have A, B, E, and F. And similar to the first question, we have A, we have B, we have E. So if we've got a fixed origin here, we should be able to do the same thing. So to find O to F, I'm going to go O to A, and then I'm going to add on, I don't know AF, so I'm going to add on BE instead. And this is equal to OE, whoops, OE minus OB. So OA was 1, 1, 2. OE, we just worked out E, it's 1, 2, 12. And OB was 2, 1, 5. Okay, great. So reading along, 1 plus 1 minus 2 is 0. And then 1 plus 2 minus 1 is 2. And then we have 2 plus 12 is 14, minus 5 is 9. Great, so there is the coordinates of f. Part D, show that B is the midpoint of FC. Okay, so we know that F is the point 0, 2, 9, and we know C as well. C was 4, 0, 1, so we'll just find the midpoint of these. And to find the midpoint, we take the average of the coordinates. So the x's, we add them together and divide by 2. The y's we add together and divide by 2. And the z's we add together and divide by 2. And this gives me 2, 1, 5, which is the coordinate B. Okay, part E, it says prove that ADPF is another parallelogram. Wow. Okay. Quickly draw the picture again. ADBF. And what I'm going to need to do is I'm going to need to show that the AD equals BF. So AD is D minus A, and D was 3, 0, minus 2, minus A, which was 1, 1, 2. And this gives us 2 minus 1 minus 4. And we're going to hope this is equal to F to B, which is B minus F, so which is 215 minus F, which was 029, and that gives me 2 minus 1 minus 4. Fantastic. Okay, now we need to find the other two sides, so let's go with A to F, which is F minus A, which gives me minus 1, 1 and 7, and then the opposite side, DB, is B minus D, and this gives me minus 1, 1, 7. Great. And then we can say as AD equals FB and AF equals DB, ADBF is a parallelogram. Oh, monster question, finished. Okay, we've got an implicit equation here. I'm always going to want to avoid the quotient rule, so I'm going to multiply by the denominator first. That's going to give me x plus 2y squared plus y, 4x minus y, is equal to 3x plus 2, 4x minus y. I'm then going to multiply out the brackets. It's going to be x squared plus 4xy plus 4y squared. This is going to give me 4xy minus y squared. And this is going to give me 12x squared plus 8x minus 3xy. And then finally minus 2y. Let's move everything over to the let's go to the right side. Okay, so x squared subtracted gives you 11x squared. We've got a minus 3xy, and then we've got 8xy there, so when that comes over to the other side, it's going to be a minus 11xy. We've got a 4y squared minus a y squared, and when that comes over to the other side, it's going to be a minus 3y squared. And then we've got a plus 8x and a minus 2y. Okay, great. Now we're going to need to differentiate. And let's identify first the products. We have, this one is a product. And that's it. Okay, great. So when we differentiate this with respect to x, this gives me 22x, and then this is a product, so I'm going to leave the left-hand side alone and differentiate the right to get dy by dx, and then differentiate the left-hand side to get minus 11, and then leave the right one alone. This is implicit, so that's going to give me 6y dy by dx. This is going to give me just 8, and this is going to give me 2 times y dy by dx. Okay, we need to make dy by dx the subject, and I can see here that we've got a plus 8, which is going to be this plus 8 here. So let's move all of the dy by x terms to the left-hand side. And they're all negative actually, so that's perfect. So when I move them all to the left-hand side, and I'm going to factorise at the same time, just to save a bit of time. How many dy by dx's do I have? Well, I've got 11x, I've got 6y, and I've got plus 2. And that leaves me with 22x minus 11y plus 8. And then all I need to do now is divide through by that factor. So I get 22x minus 11y plus 8 all over 11x plus 6y plus 2. And k is the constant to be found. Oh, okay. Oh, it's 11. Yeah, it's 11. I can see how that works. Right, k is 11. Yep, that works. Phew. Okay, find the gradient at each of the points on C where x equals 2. Right, first I'm going to need to know what the y coordinate is. So let's find the easiest equation, and that will be this one, I think. That's the equation of the curve that we just rearranged by multiplying and then simplifying and setting equal to 0. So that's going to tell me what the y coordinates are when the x coordinates are 2. So part B, x equals 2 implies that 0 is equal to 2 squared times 11 is 44 minus 22y minus 3y squared plus 16 minus 2y. Okay, let's move the y squared, the 3y squared over to that side. That's minus 24y. Let's move it over to make positive 24y. And then we've got 44 plus 16, which is 60. So let's move that over to give you minus 60 equals 0. Let's divide 3 by 3 to get y squared plus 8y minus 20 equals 0. And this will be y plus 10 y minus 2, which gives me y equals minus 10 and y equals 2. Okay, so that gives us two coordinates. It gives us x equals 2, y equals 2, and x equals 2, y equals minus 10. So we're going to need to sub those into dy by dx, which is not going to be fun. I'm going to do it on my calculator and I'm going to speed it up. Okay, there's the first one, me subbing into 2, 2, and that gave me 5 over 6. And there's the second one, which gave me dy by dx is equal to minus 9 over 2. Okay, show by using algebra that the sum of the integers between 1 and 600 inclusive that are not divisible by 3 is 120,000. Okay, so what we can do is we can first work out all of the sum of all of them. So the sum up to 600, if I'm counting all the numbers, will be 600 over 2 multiplied by 2 times by the first number 1 plus 600 minus 1 times by the difference of 1. So this is going to be 300 times by 2 plus 599. So this is going to equal 300 times by 601. And we get 180,300. So these were all the integers in total, and the next one I'm going to work out is all the multiples of 3. So I'm going to sum up 200 terms because there are 200 multiples of 3 up to 600. So that'll be 200 over 2. The first term will be 3, so 2 times 3, plus, again, 200 minus 1 is n minus 1, and the common difference between the terms is 3. Okay, so this is 100 multiplied by 6 plus 199 times 3, which is 597. And then if I add 6 to it and then multiply it by 100, I will get 60,300. And I need to subtract because we're looking for all the numbers which are not divisible by 3, so I'm going to take all the numbers and divide and minus the ones which are divisible by 3. And when I subtract, I get 120,000. Okay, question 7. We have this lovely looking picture here, which is the region that shot putters use in a throw when they throw the shot. The region consists of a minor circular sector, which is this larger one at the top, and that has a radius of 12 root 3 and subtends an angle of theta, and the chord AB is 36. And then we've got also the major one, which is this big reflex angle down the bottom, which has a smaller radius, which I'll put on there, of 3 root 3. And we need to work out what the angle is. Okay, so we're going to use the cosine rule, because we know this side, we know that side is also going to be the same, and we know this side here is 30, so we should work out the angle. Okay, so we know that cosine theta is equal to b squared plus c squared minus a squared over 2bc, and b squared was 12 root 3, so 12 root 3 squared plus the other side was also 12 root 3 minus a, which was 36, all over 2 times 12 root 3, 12 root 3. Okay, I'll put that in my calculator, and that gives us minus a half. So then we just need to do cos to the minus 1 of the answer, and we get 2/3 pi. Okay, great. Part B, it says find in terms of pi the total throwing area of the region. Okay, well, we have one sector where we know the radius and we know the angle now. and we have another sector where we know the radius and we can work out the angle because it will be the complement of the of theta. And we know that the area of the minor sector is going to be a half r squared theta, which is a half 12 root 3 squared times by 2/3 pi. 12 root 3 squared is 144 times 3. We then need to divide that by 2 and then times that by 2/3. And that gives me 144 pi. And then we need to work out the area of the sector below. That's also a half r squared theta. Oh, well, it's not actually theta, is it? It's 2 pi minus the theta. And the radius there was 3 root 3. And 2 pi minus 2/3 pi is 4/3 pi. Okay, so we need to do 1/2 multiplied by 3 root 3 squared times by 4/3, and that will give us how many pi? That's 18 pi. And therefore the total area is 144 pi plus 18 pi, which is 162 pi. Okay, next we need to work out the total perimeter of the throwing region above. Okay, so we're going to need the arc length of this one, we're going to need the arc length of this one, and then we're also going to need this distance here, which is the longer radius minus the shorter one, and we're going to need to double that. Okay, so part C, we're going to need the arc length of the the minor sector, sorry, and the arc length is just r theta. So this is 12 root 3 multiplied by 2/3 pi, and this is going to give us 8 root 3 pi. We're also going to need the arc length of the one down the bottom. This is r, and it'll be 2 pi minus alpha, theta, sorry. And the radius of that one was 3 root 3, and we know the angle was 4/3 pi. So 3 and 3 will cancel, so this is 4 root 3 pi. And we also needed those radii. We needed the straight edge. That was the difference between the two radii, and then there were 2 of them. Okay, so that's going to be 9 root 3 times 2, so that's going to be 18 root 3. So the total perimeter will be 8 root 3 pi plus 4 root 3 pi plus 18 root 3. So take the root 3 out, that's going to give me 12 pi plus 18. How do they want it? They want to take out the 6 as well? Yep. So 6, 2 pi plus 3 times by root 3. I think that's how they have it. Perfect. Okay, a lovely looking trig question. It just says find the solutions. So we're going to want to use our double angle formula for cos first. Hopefully we get some simplification. So cos 2 theta is cos squared minus sine squared, which is always the best one to substitute in if you don't know exactly where you're going to go with the simplification. And that's equal to 1/2. But cos squared minus sine squared is the difference of two squares. So I can write that as cos theta minus sine theta and cos theta plus sine theta all over cos theta plus sine theta, and that equals 1/2. And that is great. We can divide through there to simplify, and I can multiply out this top line to get cos squared theta minus cos theta sine theta is equal to 1/2. Okay, not super obvious where to go from here, but when I've got a cos and a sine times together, I'm normally thinking that a good idea would be to convert that into sine 2 theta. And I've also got this cos squared here, which I know we can use the double angle for cos theta there, so we could get two double angles come out of this. So let's give it a go. First off, I'm going to times through by 2. Okay, and hopefully we can now see these double angles a bit clearer. So what I could do is I can minus the 1 over to this side, and I can move this one over to that side. Because 2 cos squared minus 1 is cos 2 theta, and 2 cos theta sine theta is sine 2 theta. Okay, great. And then what we could do is we could divide both sides through by cos theta, or sorry, cos 2 theta, and sine 2 theta over cos 2 theta is tan 2 theta. Wonderful. Okay, tan to the minus 1 of 1 is of course 45, or pi over 4. So this gives me 2 theta is equal to pi over 4. Let's double check the range. And we're between 0 and 2 pi, which means that if we have 2 theta, then we are between 0 and 4 pi. For pi, it repeats for tan, it repeats every pi. So we just add on a pi, and then another one, and then another one. That's just over 3, so we can add on another one. And in fact, that's over, isn't it? That's over 4 pi, so that's no good. And then we just divide through by 2. So we get pi over 8, 5 pi over 8, 9 pi over 8, and 13 pi over 8. Beautiful. We have functions. It's defined by 2 plus root x. X has to be greater than 0. Evaluate f of 49. Okay, so let's first off sub in 49. This gives me 2 plus the square root of 49, which is 2 plus 7, which is 9. So therefore f of 49 is equal to f of 9, which is equal to 2 plus root 9, which is equal to 2 plus 3, which is equal to 5. Find the expression for the inverse function. Okay, so that's part A, this is part B. We set y is equal to the function 2 plus root x. we then swap x for y. We then make y the subject, and then we square, and then we finish off by saying that that is the inverse function of x, x minus 2, all squared. Sketch on the same axis the graph of f of x and f of minus x. Okay, can do that. X, y. We will start by sketching f of x, which has a y-intercept of 2. And then we're at the square root graph, which looks like this. And then the inverse function is x minus, let's just label that f of x. And then the inverse function is x minus 2 all squared, so that's a quadratic, and when y is 0, it passes through x equals 2. So there, and it's going to have a quadratic nature, like so. We might consider putting this part of the graph on, but we're not going to do that because the domain of the inverse, so all the x values you're allowed to put into the inverse, is the same as the range of the original, and the range of the original is anything greater than 2. So, or 2 or greater, sorry. So that means that we're only allowed to put x values of 2 or greater into the inverse function. It also asks me for the line of symmetry, and that will be the line going through y is equal to x, like so. Okay, next we're asked to solve f of x is equal to its inverse. So we might want to set up this equation like this, but that would be quite difficult to solve because we're going to get an x squared, a root x, and an x. So instead, what we're going to do is we're going to solve the orange and the green line, because that's going to have the same point as when the red line meets the green line. So the orange line is x, and the green line is x minus 2. So we're going to solve that, and this is going to give me x squared minus 4x plus 4. So we get 0 is equal to x squared minus 5x plus 4. So this is going to give me 0 is equal to x minus 1, x minus 4. So we're going to get x equal to 1 and x equal to 4. But we're going to have to reject x equals 1 because remember, like we said, the inverse function does not take values which are less than 2. So x equals 4 is the only solution. Okay, got a lovely looking differential equation here. We will solve it by separating of variables as always. So the first thing I'm going to do is multiply, no, not multiply. I'm going to subtract the y squared. And that way I can split up the x's and the y's by taking out a factor of x. Taking out a factor of y squared. I can then multiply both sides by dx, and that tells me I want to keep all of the x terms on the right and all the y terms on the left. So this will give me 1 over y squared dy when I divide through by y squared, and I'll also divide through by e to the x, so I'm going to get x minus 1 over e to the x dx. And then now that the variables are separated, I can integrate both sides. So I'm going to just rewrite them in a better form for integrating. And this will be x minus 1 e to the minus x. Okay, so now integrating the left-hand side, we're going to up the power by 1, and then divide by the new power. And over here we're going to do integration by parts. So I'm going to let u equal x minus 1, and I'm going to let dv by dx equal e to the minus x. I'm going to differentiate this one to get du by dx is equal to 1. I'm going to integrate this one to get minus e to the minus x. And then integration by parts tells us we do u times v, so that's x minus 1 times minus e to the minus x, and then we subtract the integral of du by dx times v, so that will be minus e to the minus x. Okay, great. Let's write this out again. So minus x minus 1 e to the minus x, and then this is going to give us a minus e to the minus x plus c. Is that right? Yes, because that gives us a plus and then there's a minus there. Perfect. Okay, great. Next we could do is we can just get rid of the minus signs by multiplying everything through by minus 1, like so. We don't need to change the constant because the constant is just constant. It can be positive or negative. And then what we're going to do is we're going to substitute in our initial conditions. So we get that y is equal to e, so this is e to the minus 1, and we get x is 1, so that cancels out to 0, and this we get e to the minus 1 plus c, so therefore c must equal 0. Okay, so we have y to the minus 1, which is 1 over y, is equal to, and let's expand this out, so I get x e to the minus x minus e to the minus x, and then plus an e to the minus x, and c is 0. So those cancel, so I get 1 over y is equal to x e to the minus x. And then finally we can take the reciprocal of all of these, so this gives me y, 1 over x, and the reciprocal of e to the minus x is just e to the x. And I think that is what they asked for. Perfect. Okay, we've got a road accident. Fuel is leaking from a tanker onto a flat section of motorway, forming a circle of thickness 3 millimeters. Okay, so we're going to have almost like a cylinder essentially, which has a thickness of millimeters, and we've got here meters and meters, so we have to convert this into meters. So 3 millimeters is 0.3 centimeters, which is 0.003 meters. So this is 0.003 meters. And of course it has a radius, we'll call that r. And we know petrol is leaking at that rate, and it's asking us to find the rate at which the radius of the circle is increasing. Okay, so we know the volume of this oil spill is like a cylinder, so it will be pi r squared multiplied by the height, which we know is always going to be 0.03. Okay, and then what we can do from this is we can find dv by dr, which is going to be helpful. So the 2 is going to come down, multiplied by the 0.003 pi to get 0.006 pi, and drop the power down by 1 just to get r. Okay, using this line here that petrol is leaking at a steady rate, this tells me that the volume is changing with respect to time at 0.0008. Okay, and now what we can do is we can find the rate at which the radius of the circle is increasing. So what we need is dr by dt, and we can flip this one over, so dr by dv, and multiply it by this one, dv by dt. The dv's will cancel and we get equality on both sides. Okay, so it's the flip of this, so it's 1 over 0.006 pi r multiplied by 0.0008. Okay, so let's just quickly put this into our calculator. So it's that over this, which is 2 over 15, and there's also a pi and r on the bottom. So this is 2 over 15 pi r. Okay, great. Now what we want is at the instant when the radius is 6 meters. Okay, so dr by dt at the point when r equals 6 is equal to 2 over 15 pi times 6, which is equal to 2 over 90 pi, which is 1 over 45. Sorry, it's 1 over 45 pi. Yeah, perfect. Question 12, we have y is equal to arc sine x, and it says by finding dx by dy and using the appropriate trigonometric identity, show that dy by dx is equal to that. Okay, so we start by taking the sine of both sides, which gives me sine y is equal to sine arc sine, our function and inverse functions, they cancel, so just x. Next, we're going to do what they say and differentiate with respect to y. So this is going to give me cos y, and this is going to give me dx by dy. Okay, great. An appropriate trigonometric identity is that cos squared x, or in this case y, cos squared y plus sine squared y is equal to 1. So we know that cos squared y is equal to 1 minus sine squared y, and therefore cos y is equal to the square root of 1 minus sine squared y, plus or minus. Okay, so this gives me dx by dy is equal to plus or minus 1 minus sine squared y, but we can sort out whether or not this is plus or minus given the range of y. So it says that y is between minus pi over 2 and pi over 2, so I'll just write that down here. So we can work out how cos y acts between those bounds. So we have pi over 2 here, and we have minus pi over 2 here, and cos is going to look like this. So therefore it's between 0 and 1. So that we know that cos y is bounded between 0 and 1 for those y values, which means that cos y, which we've just worked out as dx by dy, has to be positive. Okay. Next, what we can do is we can replace sine squared with x squared, because we know that sine y is equal to x. And then finally, we can take the reciprocal of both sides, which gives me 1 over 1 minus x squared, rooted. Great. Okay, that's part A. part B, we have y is equal to arcsine 2x, and it wants me to find dy by dx. Okay, so we have y is equal to, sorry, what was it? It was x arcsine 2x. X arcsine 2x. Okay. So this is a product rule. We've got two functions here. So what I'm going to need to do is to find dy by dx. I'll start by differentiating the first one, which gives you 1, and timesing it by this one left alone, which is arcsine 2x. And then I'm going to leave the first one alone and differentiate arcsine 2x. Okay, I'll just do that over here. So y is equal to, let's say y is equal to arcsine 2x, and I want to differentiate this. So I will say that y is equal to arcsine of u, where u is equal to 2x. So using the chain rule, if I differentiate this, well, I know what the derivative of arcsine is. It's 1 over root 1 minus the input squared. So u dash is equal to 2, and the chain rule says that we just need to multiply these bottom two together, so I'm going to get 2 lots of the square root of 1 minus, and u squared is 2x all squared, which is 4x squared. Okay, great, so that is my derivative of arcsine 2x. So I need to times that by 2 over the square root of 1 minus 4x all squared. Okay, so that's my derivative, and it wants me to sub in when x equals 1 over 4. Okay, so dy by dx at x equals 1 over 4 is going to equal, well, let's sub it, times it by 2 is a half, and arcsine of a half is 30, or pi over 6. And then next I'm going to get x, which is a quarter, multiplied by 2 over the square root of a quarter squared is a 16th, times 4 is a quarter, 1 minus a quarter is 3/4. Root 3 over 3. Great. Okay, final question. Looks like a bit of a beast, but thankfully Mr. MadAs has been kind enough to hint that you may find this substitution useful. Pretty sure we're going to find it very useful. Right, let's do it. So first things first, I would always differentiate the substitution. I'm going to do it implicitly, so I'm going to get 2u du by dx is equal to just a. So therefore 2u du is equal to a dx. So dx is equal to 2u du over a. Okay, that's going to be useful. We also know that obviously u is equal to the square root of ax minus 1. And also quite useful is that ax is going to equal u squared plus 1. And I'm also going to need to rejig my limits. So in terms of x, I have 17 over a, and I have 2 over a. So in terms of u, I'm going to sub into here, so 17 over a times a is 17, minus 1 is 16, square root it gives me 4. And 2 over a times a is 2, minus 1 is 1, square rooted is 1. Okay, I think we are ready to go. So we're going to be integrating between 4 and 1. We have on top 2ax, which is 2 lots of this, u squared plus 1. And on the bottom, we have the square root of ax minus 1, which we know is u. And dx is 2u du over a. Okay, great. Well, a is just a constant, so we can take that out. But first off, let's cancel the u's here. Let's take an a outside of the bracket, and let's also take a 1 over a, because a is on the bottom. We've got a 2 times 2 on the top, so let's take that out. So we have 4 over a we're taking out as our constants, and this just leaves me with u squared plus 1 du. Perfect. Okay, let's integrate this now. Up the power, divide by the new power, so u cubed over 3, and that 1 integrates to u. Between 4 and 1, and don't forget our factor outside. Subbing in 4 is going to give me 64 over 3 plus 4. And sub in 1 is going to give me 1/3 plus 1. Okay, I'm just going to do that on my calculator. So 64 over 3 plus 4 minus 1/3 plus 1 over 1/3 plus 1 is 4 over 3. So that gives me 24. And of course I've got to times it by 4 over a. So this is going to give me 4 times 24 is 96. So 96 over a. And we are done. Superb. Thanks very much for watching. If you enjoyed it and found it useful, please subscribe to the channel, click that button, and I've got more A-level content that way. Check it out. Bye for now.